Hey, recording's rolling. It's Wednesday, April 22nd. So we're going to do notes on Cramer roll today. So this is still part of 11.4. Now, yesterday, I walked you guys through determinants, which your book also put in 11.4. But there's some interesting things you can do with determinant. Okay, like, you can find the area of a triangle if you know the coordinates of its vertices, right, which I'm not doing with you guys, but if you're curious about that, then of course you can open your book and look at the example of how to do that. Actually, actually, you know what? I did do that on a longer video. Last weekend I recorded a longer video, found the area of the Bermuda Triangle here. Right, so, walk you guys through that example. Okay. But something else you can do with determinants is you can solve systems of equations. And the way you do this is a funny process called Cramer's rule. So I'm going to do two examples with you guys, have you guys turn this in and give you guys points. And then there were some that I circled in the packet, these three right here that are Cramer's rule. Okay. So what is this here? So I'm just going to do number 33 straight out of your book. It says this, negative 2x plus y. Okay guys, everybody's taking notes. Minus 6z equals negative 22. Okay. Hey guys, do you guys see three different variables here, x, y, and z? Okay, so I need three independent equations to be able to solve for x, y, and z. So I have two more equations. We got an 8x plus 2y plus 7z is equal to 47. And negative 8x plus 4y plus 9z is equal to negative 55. Alright, so we'll start with that. Now, there's different ways you could solve system of equations. If you wanted to be really fancy with like substitution and elimination, you can do that. But there is a process where you can make a matrix out of this. So let's take the coefficients on these x, y, and z terms, everything to the left of the equal sign. We're going to make a 3x3 matrix out of that and find the determinant, and then hang tight because we're going to use that later to eventually solve for x, y, and z. So I'm going to find what's the determinant of negative 2, 1, negative 6, 8, 2, 7, negative 8, 4, 9. Find that determinant. Okay? And I showed you guys two different ways to find the determinant of a 3x3 matrix yesterday. Okay? One method involved taking these first two columns and copy paste them over here. Here, I'll just go ahead and do that method. Okay. So, right, these columns over here. Right. Actually, your book really focuses on this particular method that I'm doing. Okay. And then to look at the diagonals. Remember, there were diagonals going this way. Then there were diagonals going the other way. And we're going to multiply each set of three numbers, add them up one way, subtract the other way. Okay, so let's figure this out. Okay, so everything in pink is going to be negative 2 times 2 times 7, and then plus 1 times 7 times negative 8, and then plus negative 6, 8, and 4. Let's see what that comes out to. It's not his move. Negative 2, 2, 7, 1, 7, negative 8, negative 6, 8, 4. Okay. I'm getting negative 276. Is that what you guys are also getting? Negative 276? Good. Okay. So that's everything in pink. Now let's switch over to everything in blue, those blue diagonals. And so looking at negative 8 to negative 6, 4, 7, negative 2, and 9, 8, 1. Okay, I'm getting 112. Right, and then if you do the pink minus the blue diagonals, that's the determinant of that matrix. Okay, so let's do negative 276 minus 112. Yeah. Yeah. Okay, so I'm getting negative 388. Okay. Right. Now I'm gonna call that the determinant. Well, I'm gonna put C for Cramer. That's what that could be. C could stand for Cramer. Okay. Now we're gonna hold on to this number and come back to that later. All right. You guys got that?
Hold on.
You know the numbers that we haven't done anything with yet are the answers on the right side of the equals. It's negative 22, 47, and negative 55. What we're going to do with those numbers is we're going to make a new matrix and we're going to substitute them in the place of, well, each one of these columns. We got an X column, a Y column, and a Z column. Okay, and that'll be the next step. Okay, so you guys ready for next? No?
How did you get negative?
Let me double check. Negative 2 times 2 times 7.
It's not 7, it's 9.
Yeah, it's not 7, it's 9.
Mr. Griffin.
Yeah.
For the pink, it's not.
Yeah, 8 through
7,
3 is supposed to be
9.
9, not 7.
Sure.
8.
Like for pink, you said negative 2 times 2 times 7. It's negative 2 times 2 times 9.
Oh, yeah, you're right. That's 9 right there, isn't it? Okay. Yeah. Okay. Yeah, so that's 9. Here, go back and find that again.
It's negative 284.
Okay. Negative 284. Okay. Very nice. There you go. All right, good catch. All right, now you guys got that. Got that. All right, now we got that. I'm gonna make a new matrix. But I'm gonna take each of these numbers on the right side of the equals, and first I'll substitute them for the x values in the first column. So negative 22, 47, negative 55. Now it still have a 1, 2, 4 in the middle column, and a negative 6, 7, 9 in the last column. And then I need that determinant. So do the same process that I did before.
Can you move the paper off of the baby down?
Need that?
Wait, Mr. Griffin.
Yeah.
This is 11.4, right?
Yeah, this is 11.4. Yeah.
Wait, what question are we talking about?
This is number 33.
Oh, okay.
Yeah.
Yeah, that's one of the June, so some of them, when I get my cards down. Like there will be 0 score. Be in my name on two. There's no money, obviously, but still.
A year ago.
Yeah.
You spend that shit recently.
Yeah.
You said what about it, though.
Not just gonna do
You are, you have some. That's fucking.
I know.
You just can't
Okay, so you guys got that determinant?
I don't know. There she is, don't see. No, last year, no, almost 2 years.
Oh, yeah.
We're not like in certain buildings, but. If you like a nice thing black one, you should. That's so.
I bet 20 grand share will get some all combined all of that.
Now, the value x is going to be equal to what we just got divided by this Cramer determinant, which is 1996. There's x.
How do you know the sex? Not any others.
Because we replaced in the x column the answers. So remember, we substituted for the x column? Yeah, okay. And we'll also do that for y and then z. Okay. And so we got one variable, we got x. Okay, you guys go with x? All right, let's get y.
Hold on.
No, no.
Cause then.
Steven, that was.
All right, so for y. So new determinant. So -2 is now in the y column, I'm not going to use these values. I'm going to use the answers over here. So now we need that determinant. So there's that determinant.
Yeah.
Oh, it's a 2000 negative, 2026, is that negative? Oh, never mind, never mind, never mind. Oh, no.
All right, and then the value y is equal to that determinant divided by the Cramer determinant. Cramer. Cramer. Cramer.
My next daddy one.
And there's y. All right, so we got x, we got y. Now we just need to get z.
What was X? I know it's 6, but like, you find it.
Okay, so for any, so let me back way to the beginning. So we had this system of equations. We're going to use matrices to determine the solution. And we took these coefficients on the left side, made a 3x3 matrix, and then found the determinant, and I'm calling it the Cramer determinant. Okay, so we hold on to that number. Then we go back and construct exactly the same matrix, except that I'm going to replace all the x coefficient column numbers with the answer values. And we found that determinant, which is this number, then divide by the Cramer determinant, and that will tell us the value of x. Then I did the same thing for y. Made the 3x3 determinant, got all the coefficients except in the y column now, I have all the answers. Found that determinant, divided that by the Cramer determinant, and that gives me the value for y. Alright, you guys ready for z? Alright, so z time.
My time. What's that?
Now, in the place of the z column, I wrote those three answer numbers. Okay, all the other coefficients on x and y are there, but not for z. For z, I put all those answers. Okay, let's find the determinant.
Last time. No, those people on the night I'm solo player. Alright. You could spoken that long. I do care if you put my pocket. Okay, so it was in this. I moved here and you can't it's you can't do. Here's somewhere else. Just go back up there. Then you go to everybody because there's mine. Ain't that right, Zeke? How does she take that run? What? Who's I don't think that's not mine. Oh my god, yes. I'm gonna go straight for him. I'm going straight for him. I don't care.
Why do you need 5 minutes? You already found the X in the Y.
I'm talking straight to a corner.
Yeah, you could. You're right. There's multiple ways you could get to the answer, and then this is the Cramer method. And then divide by the Cramer determinant. So let's say z is going to be equal to 1.
I would find the original one without any of the stuff.
Yeah, you just take the coefficients from x, y, and z and turn those into a 3x3 determinant. Okay.
We got another one.
All right. Now that we have x and y and z, so I got x is 6, y is -4, z is 1. Okay. I could check my answer
I didn't think you.
by plugging, picking any one of these equations, and it should work out. Because let's say I pick this middle one right here. Let's just middle one. Let's say I get 47 out of plugging those values in. So 8 times my x was 6, so 8 times 6, plus 2 times my y was -4, and plus 7 times, well, z was 1. And, oh, look, it is 47. It is 47. You see it? And of course, I could have done that on the other two equations. Software.
Go back to X.
He's going.
Back to X.
He's going.
Nope.
Okay.
There's a group, I think we're going one example, but we don't have to.
You're good.
Yeah, it is kind of repetitive. Do you guys think?
Yeah, we're good.
You could read that up
This
for one?
one's very good. Yeah.
Anyway, let's do this.
Hey, good again. You lasted way longer than he did.
What do you guys want for homework? Do you guys want to do 1 or 2?
We just need to do one.
Yeah. Alright, how about
That was really.
how about 31? Here guys, let's shorten this a little bit because that was a long process, but it is kind of repetitive over and over again.
Yeah.
Okay, so here I'm gonna scratch some of that out. Guys, can you do the I'm not gonna necessarily look for this. Yeah, it's a long process, but it's like same thing over and over. Alright. Alright, guys, double check, make sure your name's on your notes, and I will put those in the grade book for you.